This video is on how to find the exact values for sine, cosine, and tangent of 45 degrees. So if you pull up a calculator and you were to type in sine of 45, you get this answer right here. But just looking at it, you can probably tell that these numbers continue going. So there's probably a number after this 8. So even if you were to write out this whole decimal thing for sine of 45, that's not actually technically the exact answer. That's just an approximation. In this video, we're going to go over how to find the exact values for the sine, cosine, and tangent of 45 degrees. To start off, we're going to start off with a triangle, but not just any triangle. It's going to be an isosceles right triangle. This word right means that it's going to have a 90-degree angle. So it's going to be 90 degrees. And we're going to put that right here in this corner. All right. This word isosceles. Isosceles means that two of the sides are equal to each other. In this case, in this picture, I made this side equal to that side. I also labeled the hypotenuse as x. So the length of this, I've decided to call x. Okay. Now, with an isosceles triangle, one of the properties of an isosceles triangle is that it's symmetrical. In this particular case, it's symmetrical across this line right here. So everything to the left and to the right of this, everything to the left of this line is equal to everything to the right of this line. It's symmetrical along that line. If you were to turn the screen 45 degrees, then it'd be like the red line would be up and down, and then the left and right would look exactly the same. Okay, so because the left and right side of this red line are exactly equal to each other, and because this is already 90 degrees here, that means this angle right here plus this angle right here has to equal 90 degrees, because the three of them have to add up to 180. So that means that this angle here is 45 degrees, and the other angle is also 45 degrees. So cleaned up, here is our isosceles right triangle. We're going to use this to help us calculate the sine, cosine, and tangent of 45 degrees. All right, so let's take this picture right here, and we'll continue working from there. So here's that picture. Two of the sides are equal. One of the angles is 90 degrees, which makes the other two angles 45 and 45. I have decided to call the hypotenuse length x. It has x amount of length. All right, so how do I then find the length of our other two sides? You use Pythagorean theorem, a squared plus b squared equals c squared. Our c our c is definitely our hypotenuse. So that is the side that is across from the 90 degrees, or the really long one. So that's C. And then one of these will be A, and one of these will be B. Doesn't matter which one you choose as which. So I'm just going to choose this one as A, and I'll choose the other one as B. Okay. So let's substitute into Pythagorean's theorem. C is equal to x, so I change the c into an x. Now, for this particular triangle, A and B are equal to each other. So I'm going to change either one of the A's to a B or one of the B's to an A, which I can do because they're equal. So here I've decided to change this B right here into an A. At this point, we're going to solve for A, because once again, we're trying to find the length of these two sides. So a squared plus a squared. This is 1a squared plus 1a squared equals 2a squared. In order to get this a by itself, I want to get rid of this 2. Since this is 2 multiplied by a squared, I'm going to divide both sides by 2. 2a squared divided by 2 is just 2a squared. This one divided by 2 just looks like that. Okay, and now to get our square to go away, so a is by itself, I'll do the opposite of exponent 2, which is square root. If I square root a squared, I get a, and then this was put underneath square root. Just for the record, technically I'm missing half of this. If you square root a squared, there should be 2 answers. There should be the positive version of the square root and the negative version of the square root. But in this case, since a and b are the lengths of our sides, only the positive one really matters. We're not going to have a negative length for this particular triangle. So let's continue to simplify. Here, this is a 1 in front of this x squared. So square root of 1 just becomes 1. Square root of x squared is x. And square root of 2 is still square root of 2. Okay, and so now I've simplified it a lot, but in mathematicians have decided that one of the conventions, one of the ways they write things when they simplify is they don't want square roots on the bottom of the fraction. So to get rid of this square root on the bottom of the fraction, I'm going to multiply by 1. And here, right here, is what I mean by multiplying by 1. Multiply by square root of 2 divided by square root of 2. That is just the number 1. And multiplying by 1 shouldn't change the value here on the right. So 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. So my a value, the length of side A, is square root of 2 divided by 2, x. So that is how long this side is, my a. And b is also that same length, because those two sides are equal. So here we go. Our two sides are square root of 2 divided by 2x. If this side's length is x. Okay, so now let's use this triangle right here to find sine, cosine, and tangent of 45 degrees. Quick reminder with our sine, cosine, and tangent that sine is opposite divide hypotenuse, cosine is adjacent divide hypotenuse, and tangent is opposite divide adjacent. SOHCAHTOA. So let's write that in here. So sine of 45 degrees is the side opposite 45 degrees, divide hypotenuse. Cosine of 45 degrees is the side adjacent to 45 degrees, divided by hypotenuse. Tangent of 45 degrees is the side opposite. Divide the side adjacent to 45 degrees. Okay, for this particular exercise, I'm just going to use this 45 degrees. There's 2 of them here, and it does not matter which one you decide to use. I'm going to choose to use this one. So that means that the side that is opposite of this 45 degrees here, if If I go opposite, I'm going to the side furthest away. So right there, that is your opposite side. And adjacent is the one next to it. So this side right here is next to our 45 degrees. Okay, so everywhere I see opposite of 45 degrees, I'm going to change that for this. So I see here it says opposite. Here it says opposite. All right. Everywhere I see the word adjacent, I'm going to switch it for this, which is the same. So this says adjacent to 45 degrees. I'll switch it for square root of 2 over 2 times x. Here I see the word adjacent again. Okay, and everywhere that I see the word hypotenuse, this right here, this x right here is my hypotenuse. So let's switch out all the hypotenuses for x. Okay, there you go. So these three fractions tell you how much sine of 45 degrees is, cosine of 45 degrees, and tangent of 45 degrees. Let's simplify this. If I have square root of 2 divide 2 times x divided by x, these two x's cancel each other out. Technically, they don't cancel. X divided x becomes the number 1. And then multiplying by 1 does not change this number. So this simplifies to become square root of 2 over 2. Get all my equal signs there. All right. The same thing happens to our cosine of 45 degrees. This x and this x will end up canceling. And once again, you have square root of 2 over 2 as your simplified version. Now here, the top of the fraction and the bottom of the fraction are the same. So therefore, everything will basically just go away. And remember, they don't actually technically cancel, like I was saying before. They just become the number 1. Like x divided x becomes 1. Square root of 2 divide square root of 2 becomes 1, etc. So here, for that one, it just becomes the number 1. So there we go. We have simplified this. Your tangent of 45 degrees is square root of 2 over 2. Cosine of 45 degrees is square root of 2 over 2. Tangent of 45 degrees is the number 1.